Hello, myself Sandeep Bhatt, Assistant Professor, Department of Electronics and Telecommunication Engineering, Rungta College of Engineering and Technology, Bhilai, affiliated to Chhattisgarh Swami Vivekanand Technical University, Bhilai. I welcome you course on Fundamental of Communication and its application. Today's our topic of discussion is mobile signal propagation. Hope you have learned about the basic of the mobile communication and the standardization of the wireless communication in last previous lectures. Let us come with the content of these lectures. We go with the radio waves, basic propagation mechanism, the propagation criteria and the various propagation modes just like indoor and outdoor. Just come with the objective of this lecture. Once you deal with this or when you come with this lecture, you will be able to understand some conceptual of the free space propagation model for mobile communication, effect of fading and on the mobile communications and some performance parameters for radio waves for propagation model. Once we deals with this the basic of radio communications, everyone should know about the concept of radio waves. The wireless medium is unreliable with limited capacity and the broadcast capability. However, only wireless technologies enable user mobility. All wireless transmissions use the same medium, which is air. Wireless communication options vary based on the frequency of operations and legal access to the accessible frequency bands. Cellular networks use a licensed 1 GHz frequency, while personal communication systems use 2 GHz range. Radio signals up to few gigahertz can penetrate the concrete structure, enabling interior applications within minimum wireless infrastructure within buildings. Outdoor radio signals do not penetrate the building at the higher frequencies, while indoor signals remain contained within them. This issue limits the choice of appropriate frequency bands for wireless applications. Wireless systems have a restricted capacity due to limited frequency spectrum that allocation for certain applications and that requiring the special strategy for development. In any mobile communication system, the cell site or the base station is always fixed, but the subscriber are mostly on the move. Due to movement of the mobile subscriber, which is surrounded by the many types of obstacles during operation, it is always under the influence of varying multipath signal environment. The received signal is quite weak in such mobile radio operating environment, which is experience the multiple reflection from nearby building and the other moving vehicles. The movement of transmitter, receiver or object in between mainly causes the rate of signal fluctuation in wireless channel in the mobile communication scenario. In mobile radio environment, types of radio path are generally considered as a direct path, the line of sight or obstructive path. Let us come with some propagation attenuation, the concept. In general, the propagation path loss increases with the frequency of transmission, that is the FC, as well as the distance between cell site and the mobile. The radio frequency operation affects the radio propagation characteristics and system design. Once we go with the basic of the propagation of attenuation, then we have a basic propagation mechanism. What exactly that mechanism? With any communication system, the received signal always differ from the transmitted signal due to various transmission impairment. Radio propagation in free space and without any obstacle is most ideal situation, but in mobile communication applications, the ideal situation is rarely achieved. The radio signal with frequency having 800 megahertz have extremely small wavelength compared with the dimension of building and other obstacles. So, electromagnetic waves can be treated simply as optical rays. In wireless signal propagation, in that environment, apart from the direct waves, the receiver will get the number of reflected waves, diffracted waves and the scattered waves. The mechanism behind electromagnetic waves, the propagations are diverse, but can generally be attributed to mainly three basic radio propagation mechanism, namely as first one is a reflection, second is a diffraction and the scattering. Let us have a look into the figure 1, which is available in the presentation. You will be able to see there is a one transmitter and the user is moving from left to right, and in between that you will find some the obstacles, that is called as the different signals you will find there. One is a direct signal from transmitter to the user, another is that is reflected from the building, another is reflected from the metal, another is reflected or mimics called as there are different scenarios we are discussing one by one. So, the first one is the reflection. The reflection happens when incident electromagnetic waves are partially reflected when they come into the contact with electrically distinct object. A propagating electromagnetic waves touches on the objects the size of which are large compared to its wavelength, such as the surface of earth, building walls and etc. Reflection can also occur due to metal reinforcement. The extent of reflection of radio waves depend on the composition and surface characteristics of the objects. The angle of reflection is equal to the angle at which waves strike the object and is measured by the Fresnel reflection coefficient. The signal strength of radio waves is attenuated during reflection, which is determined by the variety of elements such as frequency of the radio waves, the angle of the incidence and the nature of the medium, which includes the material qualities, thickness, homogeneity and so on. Generally, the higher frequencies reflect more than the lower frequencies. However, reflection mechanism often dominate radio propagation in indoor domination or indoor applications. The reflections are a source of multipath signals which cause the low strength in a signal. The reflection results in a large scale fading of the radio signal. The second mechanism is the diffraction. Diffraction is a change in a wave pattern induced by interference between waves reflected from surface or point. It is based on the Huygens principle, which says that all locations on the wavefront can be considered point sources for the generation of secondary wavelet, which can be combined to form a new wavefront in the direction of signal propagation. The diffraction occurs when the radio path between transmitter and receiver is obstructed by the surface with sharp irregular edges. Diffraction can also occur in a different situation, such as when radio waves pass through a narrow slit or edge of the reflector or reflect off from two different surfaces approximately one wavelength apart. At higher frequencies, diffraction depends on the geometry of objects as well as the amplitude, phase and the polarization of the incident wave at the point of diffraction. Diffraction often result in a small signal fading. In effect, diffraction results in a propagation into shadow region because the diffracted field can reach a receiver which is not in a line of sight of the transmitter. Consequently, diffraction is an important phenomena of propagation impairment in outdoor application such as in a microcellular area where signal transmission through a building is virtually impossible. It is less consequential in indoor applications where diffracted signal is extremely weak compared to the signal or the signal that is transmitted through relatively thin wall. The third mechanism is a scattering. This is one of the important mechanism. Scattering is a special case of reflection caused by irregular objects such as walls with a rough surface, vehicles, foliage, traffic sign, lamp post and result in many different angles of reflection and scattered wave in all direction in the form of spherical wave. Thus, due to availability of the numerous objects, scattering effects are difficult to predict. Scattering occur when the size of objects is comparable or smaller than the wavelength of propagating radio waves and where the number of obstacles per unit volume is large. Propagation in many directions result in the received signal power level, especially for a scattered. So, an incoming radio signal is scattered into several weaker outgoing radio signals. As a result, the scattering phenomena is not significant unless the receiver or transmitter is located in highly noisy environment. In radio environment, scattering provides the additional radio energy, the level that the receiver to what has been predicted by the reflection and the diffraction model alone. Scattering also result in a small scale fading effect. These three impairment to free space propagation influence system performance in various way depending on local condition and as the mobile unit moving within a cell in a cellular system. Now, let us come with the next phenomena, that is, if a mobile unit has a clear line of sight conditions with a cell site, then only reflection may have a significant effect, whereas diffraction and scattering have a minor effect on received signal level. The second one is, if there is a no clear line of sight conditions such as an urban area at busy street levels, then diffraction and scattering are the primary means of signal reception. One major adverse effect of multipath propagation is that multiple copies of signal may arrive at different phases. If these phases add destructively, the signal level relative to noise declines, making signal detection at the receiver much more difficult and unreliable. This is the problem here. The second major effect of the multipath propagation is increase in a received data errors due to intersubwall interference in a digital transmission. Another form of propagation effect is the effect of refraction. This refraction is we are discussing in second section. The refraction occurs because the velocity of electromagnetic waves depend on the density of the medium through which it travel. Waves that travel into a denser medium are bent towards the medium. This is the reason for line of sight radio waves being bent towards the earth, since the density of the atmosphere is higher closer to the earth. Then we have discussed all the mechanism of the reflection, diffraction, scattering and refraction. Now, let us talk about the something of mobile radio channel. In mobile communication system, signal experiences multipath propagation, which causes rapid signal level fluctuation in time, that is nothing but a fading. Fading is nothing but a fluctuation in signal or the rapid fluctuation in a signal. Mobile radio channel introduce noise, fading, interference and other distortions into the signal that they transmit. Fading effect that characterize the mobile radio communications are the large scale fading and small scale fading. There are two types of fading we are going to discuss now. One is the large scale fading, another is a small scale fading, or we call as a small signal fading. If there is a large number of multiple reflective paths with no line of sight signal path, it is called as the relay fading. The relay flat fading channels model assume that the channel introduce amplitude which varies in time according to the relay distortion. When there is a dominant non-fading signal component present, the small signal fading envelope is described by the Rassian fading. The small signal fading results into the signal dispersion and time variant behavior of the channel. The second one is the multipath fading. Fading in a mobile communication occurs due to a real time location changes and multipath effect. This results in the rapid signal strength changes, random frequency modulation and time dispersion due to Doppler shifts and delay in multipath propagation. Fading is the rapid fluctuation of radio signal atmosphere amplitude in a short time or over a short distance. In fact, there are two main reasons that contribute to the rapid fluctuation of the signal amplitude. Now, let us discuss there are two criteria here or two phenomena. The first one is, or we may say the two main reasons that contribute the rapid fluctuations are, the first one is the caused by addition of the signal arriving via different path is referred to as a multipath fading. What happen actually when the user is in outside, or we may say as outdoor, that time the signal when we have from the transmitter, you will get two types of signal over there, or multiple path of signal that goes into the addition. Then second one is that problem of is second reason for the fluctuation is that is caused by the relative movement of the mobile unit towards or away from the cell side transmitter, that is called as the Doppler effect. This Doppler effect when the user is coming toward the transmitter or if he is going away from the transmitter. The fading is the rapid fluctuation of radio signal, which we have done here. There are two types of reasons, right. The other factor that influence small scale fading include the multipath propagation, speed of mobile, speed of the surrounding object, and the transmission bandwidth of the signal. These three factors are very important, that is that small scale fading include multipath propagations, speed of the mobile, that is user, and the speed of the surrounding object, and the transmission bandwidth of the signal. The multipath fading results in a fluctuation of the signal amplitude because of the addition of the signal arriving with different phases. These phases difference in a cause due to the fact that signals have travelled different path lengths. It means we already seen that the signals came from the different locations, or we may say as the signal from the multipath. So, every path having different length, that is why we call as a signal travelled from the different path levels or path lengths. Then second, we have a type of small scale fading here. The type of small scale or fading experienced by the signal propagations through a mobile communication channel depends on the nature of transmitted signal with respect to the characteristics of the wireless channel, the speed of the mobile and the direction of the motion of the mobile with respect to the incoming received signal from the cell side transmitter. Fading effects in a mobile radio environment can be classified as: one is the fading effect due to multipath time delay spread, and second one is a fading effect due to Doppler speed. So, there are two types of the effect. One is due to the fading effect due to the multipath time delay spread, and second one is the fading effect due to the Doppler spread. Due to multipath time delay spread, fading effect can also be classified as a flat fading and frequency selective fading. Flat fading or non-selective fading is that the type of fading of the received signal fluctuates in the same proportion simultaneously. Flat fading occurs when the radio channels has a constant gain and linear phases response, but its bandwidth is greater than that the transmitted signal. It implies that the desired signal bandwidth is narrower than and completely covered by the spectrum affected by the fading. In flat fading, the multipath structure of the channel is such that the spectral characteristics of the transmitted signal are preserved at the receiver. However, the strength of the received signal changes with time due to fluctuation in the gain of channel caused by multipath. A typical flat fading channel causes the deep fades and can be best corrected by the increasing the transmitter power by 20 or 30 dB in order to achieve a low bit error. That error rates during the time of deep fades as compared to a system operating over non-fading channel. Here we can have a correction of that the problem due to fading, that we can increase the transmitter power, right. So, that transmitter power can be increased by 20 or 30 dB, right, for achieving the bit error rates. The frequency selective fading affects the unequally the different spectral component of the radio signal. The selective fading is usually significant only relative to the bandwidth of the overall wireless communication channel. If the signal attenuate over a portion of bandwidth of the signal, the fading is considered to be selective in frequency domain. Frequency selective fading on the received signal occur when a radio channel has a constant gain and linear phase response, but the channel bandwidth is less than that of the transmitted signal. Under such conditions, the channel impulse responses has a multiple delay spread which is greater than the reciprocal bandwidth of the transmitted signal. Here you can see in such kind of condition what actually happens, the channel impulse responses has a multi-part delay spread which is greater than the reciprocal bandwidth of the transmitted signal. That means, the frequency selective fading channels are also dispersive, which means that the signal energy associated with each symbol is spread out in a time. This causes transmitted symbol that are adjacent in the time to interference or interfere with each other. Equalizers are often used to compensate for the effect of intersymbol interference. So, here we are going to use the equalizer for minimizing the intersymbol interference. Now, due to Doppler spread, the fading effect can also be classified as a fast fading and a slow fading. This is also the one of important factor in a mobile communications. The Doppler spread is nothing but whenever the user is moving towards the tower or moving away from the tower. Depending on how rapidly the transmitted baseband signal changes as compared to the rate of change of the channel, a wireless channel is classified as a fast fading or slow fading channel. In fast fading conditions, as the mobile unit moves down a street in an urban environment, rapid fluctuation in received signal strength occur over a distance of about 1/2 of the wavelength. The channel impulse responses changes rapidly within the symbol duration. That is, the coherent time of the channel is smaller than the symbol period of the transmitted signal. This causes the frequency dispersion, also called as a time selective fading due to the Doppler spreading. This results into the signal distortion which increases with increasing Doppler spread relative to the bandwidth of the transmitted signal. Therefore, a signal undergoes fast fading if the symbol period T s is greater than the T f, the time between fades. The fast fading occurs when the rate of change of channel characteristics is faster than the rate of change of information data rates or data signal, and they result in a distortion. In a slow fading channel, the channel impulse response changes at the rate much slower than the transmitted baseband signal. As the mobile subscriber cover distances well in an axis of wavelength, the urban environment changes as the mobile subscriber crosses buildings of a different height, busy intersections, vacant places and so forth. Over this longer distance, there is a change in the average received power level about which rapid fluctuations occur. This variation of the signal strength due to the location is often referred to as a shadow fading, which is similar to a slow fading. There is one fundamental, that is shadow fading. Shadow means it is something behind, right, and it is also look like a slow fading. The shadow fading is typically modeled by attenuation in a signal amplitude that follows a long normal distributions. Now, what is exactly the effect of this multipath fading? The fading may causes rapid change in volume, random frequency modulations, echoes, distortion or the drop call. Sometimes we experience we are not getting the voice clear during when we on a call, and sometimes you will find you will have only one way communication, or we may say that someone is only listening or someone is only talking, or sometimes may happen the dropping of call. This is just because of the fading. This is the fading effect and we are experiencing in real time. The listener noticed that all these effect of the fading, the small signal fading results in a very high bitrate error. In order to overcome the effect of small fading or signal fading, it is not possible to simply increase the transmitting power because this will require a huge increase in a transmit power. Previously, we know that by increasing the transmitting power with the 20 or 30 dB, the problem will be solved, but in that case this is not possible. We can go some extent, but we cannot minimize the all things, right. A variety of techniques are used to mitigate the effect of small signal fading, such as error control coding with interleaving, diversity scheme and using directional antennas at the cell site. So, here instead of increasing the power, one should have what we have some coding techniques or interleaving, some diversity scheme and some directional antennas. Nowadays, you know very well, for increasing the coverage we have a ADS systems, or we have a different antenna systems. There is a high gain antenna that is placed on the height of the building, and some there are repeaters, that those repeaters we use to increase the coverage area. So, to minimize such kind of effect, we go with the diversity techniques. So, diversity techniques are useful to overcome the effect of fast fading by providing multiple copies of the signal at the receiver, because the probability that all these copies suffer fading is small. The receiver is able to correctly decode the received data. Frequency hopping is another technique that can be used to combat the fast fading, because all frequencies are not simultaneously under fade. Transmitting data by hopping to different frequencies is an approach to combat the fading. This is one of the important techniques where we can go, or we can say as the one is a diversity, another is a frequency hopping. So, the problem which we face here, the small scale fading, the error rate we have gone in a very higher rate. Sometimes we get a very less signal and we experience the different kinds of problem. To design such kind of the frequency hopping and diversity, the one should have the know about some propagation criteria. So, let us talk about the some propagation criteria. Every mobile radio communication system is designed with the objective of providing continuous communication with mobile subscriber that occupy the arbitrary location in a service area. The design can be optimized only if the constraint under which systems has to operate are fully understood. The most important being the accurate prediction of the path loss and estimation of the received signal strength in radio coverage area. These 2 points are very important as a criteria designer. The most important design parameter in a most mobile communication system is the achievable signal coverage, as the primary objective of the system is to serve the mobile subscriber in a specified service area. For a given transmitter power, the achievable signal coverage determines the range of operation of cell site transmitter and the size of a cell in a cellular topology. So, that is it is simple. If you have a very high power transmitter, but obvious it will cover a more area and it will reach us to the subscriber. The detailed understanding of the radio propagation model is essential for appropriate design, development and optimized performance in many, or you will find any kind of communication system. Signal propagation through a wireless media can vary significantly depending on the operating terrain, frequency of the transmission, sources of the interference, speed of the mobile unit and many other dynamic factors, and so it is heavily location specific. The wireless communication links face unique path, terrain, obstructions and atmosphere conditions, making it difficult to formulate an exact propagation path loss for all type of system in a single mathematical equations. Here it is very difficult because we do not have a complete surface area, we do not have a flat surface area. Somewhere you will find flat, hilly, the valleys are there, some coastal areas there, some where you will find the so many trees are there, up and downs are there, somewhere you will find the buildings, or in urban area complete tall buildings are there. So, it is very difficult to design the kind of particular model for the mobile communications. So, in a free space propagation model, we have different models where we use those models to mitigate all those problems. So, the first model we have here, the free space propagation model. Free space propagation model is the fundamental for all propagation path models for any wireless communication applications. A free space propagation model is used to predict the received signal strength when the transmitter and receiver has a clear unobstructed line of sight signal path between them. The free space environment could be categorized as one having less clutter and foliage. The propagation path loss model are extensively used for development of cellular communication network. The coverage of cell site depends on the power of transmitted signal and the path loss. Here we can define one more thing, that is EIRP and power density calculations. So, when we go with the kind of model design or propagation model for a free space, one should calculate or one should have a keep in mind, that is EIRP should be taken a consideration, power density calculation, free space path loss, range of the base stations transmitter, received power in a free space propagation, path loss, received power and transmission delay, power delivered to the receiver. These parameters or these performance parameters should be considered while designing a free space propagation model. Now, second we have a mobile point to point propagation model. The free space propagation model does not apply in all radio environment. The propagation path loss depends on the distance of the mobile from its serving cell site, carrier frequency of the transmission or wavelength we can say, the antenna height from the cell site and mobile unit, and the local terrain characteristics such as building and hills. Mobile radio propagation path loss is uniquely different from the kind of path losses experienced in other communication media. The signal received by the mobile unit remain constant only over a small operating area and varies as the mobile unit moves. This is mainly due to variation in the terrain conditions and the presence of man-made structure surrounding the mobile unit. The point to point propagation model is very useful for designing the mobile cellular system with a radius of 15 km or less for each cell. There are again 3 points, that is one more model we have for the 3 type of model we use in the generally we call as the free space or point to point mobile model. The first one is a two-ray point to point mobile propagation model, second one is a near distance propagation, third one is a propagation over a flat open area. So, two-ray point to point propagation model, here we will having there are 2 rays from the antenna side which will reach us towards the subscriber, and we have an angle from the transmitter and angle from the receiver also, and how much distance is covered by the total distance from the transmitter to the subscriber, that to be consideration in a two-ray point propagation model. Second model we have also here, that is near distance propagations, when the user is near to the tower or near to the antenna, that is one should know about the what angle should be there and how communication should be there. The third is the propagation over a flat open area. Suppose if person or the user is outside the or outdoor and there is nothing like the hilly area or coastal or up and downs, you will find complete flat and there is maybe a chance of so many line of sight signal or the receiver or the transmitter, they are in front of each other. Now, we have another model for that is the outdoor propagation path loss model. The radio propagation model are empirical in nature, that is these are developed based on large collection of measured data for the specific wireless communication environment. For any model, the collection of data has to be sufficiently large to provide enough likeliness to all kind of situation that can be happen in that specific environment. Like all empirical models, radio propagation model do not point out the exact behavior of a link, rather they predict the most likely behavior of the link that they may exhibit under this specified condition. Different propagation model have been developed to predict path loss over irregular terrain. Some of the most popular outdoor propagation models are, one is Acumera, second one is Hata, then CYST 231 Hata, then Longley Rice and Durkin model. These are the we say as the outdoor propagation model. Now, let us talk something about the indoor propagation path loss model. In indoor propagation environment is more hostile than the typical outdoor propagation environment. The indoor propagation model estimate the path loss inside the room or closed area inside a building delimited by the wall of any form. The phenomena like lack of line of sight conditions, multipath propagations, reflection, diffraction, shadow fading, heavy signal attenuation, close proximity of interference sources and rapid fluctuation in wireless channel characteristics have a significant influence on received power in indoor propagation. Now, as of now we have learned about the basic concept of the radio waves, some of the models, and we have also have done the fading criteria and their impact on the wireless communications and how to minimize those fadings with the help of different diversity scheme, frequency selective scheme and other scheme. Now, let us conclude this lecture. The properties of wireless media are discussed and the propagation mechanism which strongly influence on the received signal in a mobile radio environment are we have discussed here. Here we also explain the reason as why to the wireless communication is fundamentally different from the wired communications. The various impairment to the propagation such as reflection, diffraction, scattering have been discussed. As the electromagnetic waves travel from transmitter to mobile receiver, this impairment causes multipath propagation and mobile signal fade, which pose serious bottleneck in the reliable performance of the mobile communication system. Fading also discussed and their impact on communication we also discuss. In last we deals with the different propagation models. Hopefully, this article has given you an insight into the world of the propagation for the mobile radio communications and what is meant for the mankind. Thank you for listening the lecture.